and I want to move on to hyperbolas. Okay, well, I'm going to get started.
Because I was working on the CNC router.
Why are you late? Why are we late?
Working on the project.
Someone off the. Oh, wait. Is it still Great.
All right, I'm going to get started, so please stop talking. So today we're going to go over hyperbolas. So it's still the same kind of process that we've been going through for our last few sections. So first we started with parabolas, then circles, then ellipses, now hyperbolas. Okay, so similar to an ellipse, a hyperbola is the set of all points in a plane such that the absolute value of the differences of the distance from the foci is constant. You're quiet and you're taking notes, or you're paying attention. Every hyperbola has two axes of symmetry, the transverse axis and the conjugate axis. These axes are perpendicular at the center of the hyperbola. Okay, so your transverse axis goes from your vertex points. Okay, so that's the length between your two vertices. The conjugate axis is between your two co-vertices. Okay, so you have a transverse axis and a conjugate axis. Those will be helpful in finding your A and B values. Okay, so A is going to be half of your transverse axis, and B is going to be half of your conjugate axis. Okay, so that's from the center point to a vertice, from the center point to a co-vertice. The foci of a hyperbola always lie on the transverse axis. Okay, you have your two focus points here. The vertices are the endpoints of the transverse axis, and the co-vertices are the endpoints of the conjugate axis. Okay, just like with ellipses, you have a horizontal and a vertical hyperbola. Okay, so a horizontal one means your transverse axis is horizontal. Vertical, your transverse axis will be vertical. Okay, unlike with the other types that we've done so far, your hyperbola has asymptotes that are created. Okay, so that would be this line right here and this line right here, and they will cross at that center point. Okay, now your asymptote means that that graph can't cross that dotted line. Okay, so your graph will follow that general direction, but it will never cross those two lines there. Okay, so just like with ellipses, we do have some relationships in hyperbolas. So you have two axes of symmetry, and just like we had an equation to find C and B, again we have that equation here, except now it's a squared plus b squared instead of a squared minus b squared. Okay, so with an ellipse you're subtracting, with a hyperbola you are adding. So we also have our table. Okay, so again, two forms of your equation. This is the one for horizontal. Okay, and our vertical standard form. Okay, now this one is a little bit different than our ellipse. So with ellipses, we were adding. Okay, now with hyperbolas, you're subtracting those. Okay, your a squared value is always going to be in that first denominator, okay, in each. But you may have to switch your x minus h squared and your y minus k squared, depending if it's horizontal or vertical. Okay, and just like with our ellipses, we have our foci points, our vertices, and our co-vertices, and how to find those with our a, b, and c values. The only extra thing here is we have equations of asymptotes. Now the main part that you're going to need in this is this plus or minus b over a, and this plus or minus a over b. Okay, so for some of these you may be given the equation of the asymptote, and then you can just look at that slope and you can determine what a is and what b is just by giving that equation. Okay, so we are going to write the standard form of a hyperbola given a graph. Okay, so that's what we're going to do today. So at the right here, this is our hyperbola. Our vertices are right here and right here. So our first vertex is at -2, -6, and that second one there is at 8, -6. Okay, since our vertices, between our vertices we have our transverse axis. Since that axis is horizontal, that means this standard form of our equation needs to be horizontal. Okay, so you want to look for those transverse axes to see which direction they go. So this one is horizontal. Now our first step is to find our center. Okay, so we want to find that center point. To do that, we're going to use our vertices. So that's going to be the midpoint of your vertices. Okay, so we're going to average our x's here. So we have -2 plus 8 over 2. Again, I'm just using this midpoint formula. Then I have -6 plus -6 over 2, averaging my y's. So I'll end up with 6 over 2, -12 over 2. Okay, which will give me 3, -6 as my center point. Okay, now I do want to find the center because that gives me my h and k values. Okay, so now I have h and k. My next step is to find a. Okay, so to find a, I'm going to use my vertices. Okay, so I'm just going to use one of my vertices. So use one vertex. So I'm just going to use this one right here. So to find our vertice, okay, I'm going to look at my chart here. Since it is horizontal, to get a vertice, I need to have h plus or minus a in that x position there. Okay, so I need h plus or minus a to be equal to my x in my vertice. So that'll be negative 2. Well, I know what h is, so I can plug in 3 for h. Okay, subtract 3. And remember, your a and b values always have to be positive. So a will be 5. Okay, our next step. What we're going to do is find c so that we can find b. Okay, so we're not given our covertices in this graph, so we can't use those to find our b value. However, we are given our foci points here. Okay, so I can use those and find c, and then once I have c, I'm able to find b. Okay, so I'm going to use this focus point right here, negative 3, negative 6. So to find our foci points, we're going to take h plus or minus c. Okay, so I have h plus or minus c is equal to my x value for my focus point there, so negative 3. Yes. Then I can plug in h. So we have 3 plus or minus c equals negative 3. Subtract 3, so we have plus or minus c equals negative 6. Again, since that can't be negative, c will be equal to 6. Okay, now I was finding c so that I'm able to find b. Now there's a relationship among a, b, and c. I can say c squared is equal to a squared plus b squared. So now I have c and I have a. I can plug those in and solve for b. So I have 6 squared is equal to 5 squared plus b squared. Square your terms. So we have 36 is equal to 25 plus b squared. Subtract 25. Take the square root of both. And when I do that, I'm just going to leave it as a square root. So I'm going to leave it in that form, and I'm not going to plug it into my calculator. Why? Because once I plug it into my standard form here, I'm going to need to square it. And if I round that, you're going to get a decimal instead of that nice whole number. Because once I square a square root, they just cancel. Okay, so now I have h, k, a, and b. So my last step is just to write out my equation. Okay, so we want to write out that equation. And since we're using the horizontal, we'll have x minus h. H is 3 squared over our a value was 5. 5 squared is 25. Since it's a hyperbola, we're going to subtract. And then we have y minus k. K is negative 6. Over b squared. If I take the square root of 11 squared, those cancel, so I end up with just 11. Okay, and just like with an ellipse, it's always equal to 1. And then that's it.
You always have to find the point first.
Find which one first? C? Unless you're given the center point, you always want to try and find that center point first, because for your vertices, you'll use either H or K to find A. And you want to know that value so that you can find A. The next one is vertical. Okay, so our second example here is vertical. These two are your vertices. Okay, between your two vertices you draw a vertical line, so your hyperbola is vertical. Okay, with this one, I am given the center point already on my graph. Okay, it's where these two asymptotes meet. That's at -4 and -5. Okay, so for step 1, you could use your midpoint formula and find that, but since it's already given to you, I'm just going to write it out as -4, -5. Okay, and that's your H and K value. Okay, step 2 is to find A. Okay, we want to find A, so I'm just going to use one of my vertices. And since it is vertical, I'm going to use this one right here, K plus or minus A. And it has to be equal to your Y value. Okay, so that'll be equal to 1, or -1, sorry. And then I can plug in K here. So we have -5 plus or minus A equals -1. Add 5 to both sides. And A will be equal to 4. Okay. Next, what I need to do is find B. Okay, to find B, this time I don't have any focus points and I don't have my co-vertices. However, I do have my asymptote equations. Okay, so to find B, we're going to use these asymptotes. Okay, and the equation to find your asymptote for vertical is y minus k is equal to plus or minus a over b times x minus h. So the part that I want to look at with my asymptote is this part right here, because that's where I see that b value. Well, my equation's over here. I have 2/3 x and -2/3 x. Okay? So if I have 2/3 as a and b, but I know a is supposed to be 4, right? So I'm going to set this equal to 4 over b, because when you're writing an equation with a slope, you always reduce that fraction. So I want to unreduce that fraction in order to find b. So I'm plugging in my a value and comparing it to that slope they got for their asymptote. Does that make sense? Okay, so from here to solve for b, you can cross multiply. Okay? Cross multiply.
Disregard the entire,
Yeah, you don't even need this piece right here for your y-intercept. This stuff, they use this to help get this y-intercept. So you don't need these pieces. If you were to plug them in, that's fine. Your slope? and set it equal to, if you have your A value, put A on top, since that's where A is supposed to be. Okay, so I just multiplied 2 times B and 3 times 4. Divide, what? I can't hear you. Oh, 12 equals 2B? No, that's fine. Divide both sides by 2, because you should still get B is equal to 6. Okay, so you're, again, just using that slope for your asymptote. Okay, for a vertical asymptote, your slope is A over B. I believe in a horizontal asymptote, it's B over A. Okay, so that's where that difference lies. So now that I have H and K, A and B, I can write out my equation for my last step. Okay, and for my vertical, I'm taking y minus k squared.
I have a question.
Yep.
Is this rated?
Yep.
Okay.
Over a squared. So a is 4, so square that to get 16. Subtract x minus h over b squared. And it should, again, always equal 1. It is x minus h, but since h was negative, I turned it into a plus.
Is that a 5? So y plus
5.
You got a 5? Okay.
Yep.
Just looking at
So for hyperbolas, you can, if you're given the co-vertices, you can use those to find B instead. So if you're looking at your graph and it states which ones are the co-vertices, use that. But for finding A, you should just use your vertices, okay? And you should have found your center already and used that. Any questions?